4 cylinders, 2 sets of drivers, 1 rigid frame. Every locomotive that had ever turned a wheel in America before 1942 put its power through a single set of coupled driving wheels, driven by 1 pair of cylinders on either side of the boiler. The engineers at Baldwin Locomotive Works in Philadelphia built something that did neither. They called it duplex-drive. The Pennsylvania Railroad called it the future. And every man who climbed into the cab called it the most terrifying machine he had ever touched. This is the story of the T1. Have you ever stood next to a machine and felt that something about it was fundamentally wrong, the kind of wrong that means someone had a better idea than everyone else? Put it in the comments. This is what American Iron Works covers. Subscribe so you do not miss what comes next. The Pennsylvania Railroad in 1940 was the largest railroad in the United States by traffic and revenue. It operated 10,515 route miles, and in the decades prior carried nearly 3 times the freight volume of comparable railroads like the Union Pacific and the Santa Fe. The railroad's chief mechanical staff had a problem. Their premier express trains between Harrisburg, Pennsylvania, and Chicago, Illinois ran 713 miles. One stop for coal at Millbrook, Ohio, was 385 miles west of Harrisburg. The locomotives hauling those trains were K4 Pacifics, a 462 design that had served the Pennsylvania Railroad since 1914 and that the railroad's own shops had been building through 1928. They were not fast enough for what was coming. The Pennsylvania Railroad's mechanical team had been studying a specific physics problem that almost no other American railroad had named in those terms: dynamic augment. When a conventional steam locomotive runs at high speed, the side rods and main rods connecting the pistons to the driving wheels are heavy. Each rotation of the drivers swings those rods in a circle, up, forward, down, back. At 80 miles per hour, that rotating mass hammers the rail on every downstroke with a force that exceeds the locomotive's static wheel weight. At 100 miles per hour, that force is not a minor concern. It is a track destruction problem. Think of it this way: swing a 10-pound weight on a rope over your head and then drop it onto a wooden plank once a second. Now swing it at 3 times the speed. The plank breaks faster. The Pennsylvania Railroad's driving rods weighed far more than 10 pounds and rotated hundreds of times per minute. The Pennsylvania Railroad ran premium track on its main line, but even premium track has limits. Their mechanical department calculated that a single locomotive capable of hauling the same train as 2 K4 Pacifics at twice the speed while cutting rail hammering force in half would pay for itself not just in crew savings, but in track maintenance savings over the life of the machine. That was the economic case nobody talks about. The speed record was the advertising, the track protection calculation was the business. Baldwin's chief designer, Ralph P. Johnson, drew up the answer. He split the driving wheels into 2 groups of 2, each powered by its own pair of cylinders, on a single rigid frame. 4 cylinders, 4 sets of driving wheels. 1 locomotive. The Pennsylvania Railroad designated it the T1 and ordered 2 prototypes from Baldwin on June 26, 1940 at a combined cost of $600,000, equal to approximately $13.8 million today. Raymond Loewy, the industrial designer who had already styled the Pennsylvania Railroad's GG1 Electric and the Broadway Limited, was brought in to clothe the exterior of the T1. He gave it a shark-nosed, bullet-shaped shroud in dark Brunswick green with gold lettering. It had a streamlined casing that enclosed the boiler and drive machinery in fairings that looked like nothing else on an American railroad. Prototype number 6110 was completed in April 1942. Crews at the Baldwin plant called it Flash Gordon. Number 6111, its twin, arrived in May and got the name Buck Rogers. Both went to work on the Harrisburg-to-Chicago route. The test figures that came back were extraordinary. Machine efficiency was 93%. Horsepower output above 55 miles per hour was more than 6,000. Sustained speed on the flat exceeded 100 miles per hour while pulling 880 trailing tons. The K4 Pacific, which the T1 was replacing, could not match any of those numbers in the same configuration. The Pennsylvania Railroad's board looked at those results and on December 20, 1944, authorized the purchase of 50 production T1s at $14,125,000 total, $282,500 per unit. 25 were assigned to the railroad's own Altoona works. 25 more went to Baldwin. By 1946, the full fleet was in service. The first production T1 entered the roster the same week the Pennsylvania Railroad took delivery of its first EMDE-7A diesel electrics. Nobody in management commented on the timing. The T1 was the most powerful non-articulated passenger locomotive ever placed in production service in the United States, and every one of them had a problem. At speed, the front set of driving wheels slipped. A slip at 20 miles per hour is recoverable. The engineer cuts power, the wheels catch, and the train continues. A slip at 80 miles per hour is a different event entirely. The locomotive shuddered. The train lurched against the couplings. The engineer had to close the throttle completely, wait for the wheels to re-engage, and then rebuild speed from scratch. This happened on both prototypes and on the production fleet. The Pennsylvania Railroad's mechanical department wrote up the slips as mechanical failures, and the T1's reputation as a dangerous, uncontrollable machine spread through every division that ran it. There was something wrong with the duplex-drive, or there was something wrong with the men who drove it. That question was never answered because the Pennsylvania Railroad never tried to answer it properly. What railroad historians reconstructed 60 years later is that the wheel slip had two root causes, and both of them were fixable. The first was spring equalization. In the T1, the springs supporting the locomotive over its front axles were not calibrated to equalize the force between the front driving group and the engine truck, the small leading wheels at the front of the locomotive. On a straight, level track, this caused no problem. On a curve, or over any section of track that was not perfectly level, weight shifted off the front engine. When the front drivers unloaded, they had less grip on the rail. When the engineer fed full steam into 4 cylinders, pushing 64,653 pounds of tractive effort through drivers with reduced rail contact, the front wheels spun. The Pennsylvania Railroad identified this in the production fleet and split the spring rigging, equalizing the front engine with the engine truck and the rear engine with the trailing truck. The fix was applied to the production units. The slip rate dropped, not to 0, but the improvement was measurable and the direction was clear. The second root cause was simpler and more damning. The T1 had a front-end throttle, a different valve architecture than the K4 Pacific that every engineer on the Pennsylvania Railroad main line had spent their career driving. The K4's throttle response was gradual. The T1's was not. When a T1 engineer cracked the throttle, steam moved through the Franklin Type A poppet valve system, a set of mechanically operated mushroom-shaped valves, not the traditional sliding piston valves, and the 4-cylinder engine responded immediately. At full boiler pressure of 300 pounds per square inch, that response could spin the front drivers before the engineer's hand had finished its motion. The company that supplied those poppet valves, Franklin Railway Supply, certified them for sustained operation at 100 miles per hour. Franklin's own investigators, riding Pennsylvania Railroad express trains to find out why valves were failing in service, found that train crews running late were routinely sustaining speeds above 120 miles per hour. One anecdotal account places a T1 at 140 miles per hour, which would make it the fastest steam locomotive ever operated anywhere on Earth, 14 miles per hour ahead of the Mallard's world record, set in England on July 3, 1938. No instrument confirmed it. No official record exists. The valves were breaking because the crews were running harder than anyone had designed for, and nobody had told them not to, because nobody had trained them on the T1 at all. Which brings us to the number that changes everything about this story. The 50 production T1 locomotives were assigned to crews from the extra board, junior engineers, men who had spent their careers on K4 Pacifics, men who received no formal training on the T1's throttle behavior before their first run. The two prototypes, number 6110 and number 6111, were run almost exclusively by senior engineers, and the prototypes had almost none of the same problems as the production fleet. That asymmetry sat in the maintenance records. Nobody looked at it as evidence. In the spring of 2008, a researcher working through the Pennsylvania Railroad Technical and Historical Society's archives published an article in the Society's magazine. The finding was that the T1's wheel slip reputation was built substantially on a training failure, not a design failure. The engineers transitioning from K4 locomotives were opening the T1's throttle the way they had opened K4 throttles their entire careers. The T1's response was nothing like a K4. The front wheels spun. The men wrote up the slip. The railroad blamed the machine. By 1948, Pennsylvania Railroad President Martin W. Clement had already made the decision that ended the T1 program. Clement announced in the spring of that year that by May of that year, they expected all of their important east-west through passenger trains to be diesel-powered west of Harrisburg. The Pennsylvania Railroad's spring equalization fix had been applied. The Franklin valve experiments on number 5500 and the Walschaerts gear conversion on number 5547 were underway. Neither experiment had time to produce conclusions. Clement's announcement came first. The T1s were moved off express service and onto mail runs and secondary trains through 1949. All were out of service by 1952. Scrapping began in 1951, and the last T1 went under the torch in 1956. 52 locomotives, not one preserved. The Pennsylvania Railroad was the largest railroad in the United States, and it could not spare a single example of its most ambitious steam locomotive for a museum. Raymond Loewy's bodywork had not helped matters in the roundhouse. The streamlined shroud that made the T1 the most photographed American steam locomotive required maintenance crews to cut through fairings to reach the machinery underneath. The T1 also ran dirty, tarnished, and smoke-streaked despite washing, because the casing trapped residue that conventional locomotives shed into the open air. The beauty that made the T1 famous in photographs was a daily operational problem in every shop that handled it. In 2014, a non-profit organization called the Pennsylvania Railroad T1 Steam Locomotive Trust began building the 53rd T1. They worked from original blueprints pulled from the Pennsylvania State Archives in Harrisburg. The locomotive carries the next available number, 5550. As of May 2026, number 5550 is 65.4% complete. The frame is done. Cylinder work is in process. Final assembly begins in 2026 at a facility in Denison, Ohio, the same depot where Pennsylvania Railroad staff served over 1 million American soldiers passing through during World War II. When number 5550 fires up, the T1 Trust's stated goal is not excursion service. The goal is a world speed record attempt against the Mallard's 126 miles per hour, set in England on a downgrade test run in 1938 and never matched on a level track anywhere. The T1 Trust believes the original T1 design, properly maintained and properly operated, is capable of exceeding 140 miles per hour. This raises a question the historical record cannot answer cleanly. If the wheel slip was primarily a training problem, and the spring equalization fix addressed the mechanical root cause, and the poppet valve experiments were pointing toward a more reliable system, was the T1 actually a failed locomotive, or was it a functional locomotive that the Pennsylvania Railroad scrapped before the remediation could finish? The engineers who drove number 5550 will have an opinion on that. The 2008 findings point in one direction. But the men who drove the production fleet on the extra board, the men who received no manual, no classroom instruction, no simulator time, nothing, took the write-ups for slips they had not been taught to prevent. Their names are not in the official record. The institutional verdict found the machine deficient. The machine is now being rebuilt. What do you think the record will show when number 5550 makes that run? American Iron Works covers the engineering decisions, the economic logic, and the institutional forces that shaped the machines most people have already forgotten. Subscribe to American Iron Works.